Okay team, so in this video, we're going to do what we did in the last video, but instead of doing it graphically, we're going to do it analytically, which essentially means algebraically. And I misspelled analytically, which is great. So what that means is instead of having the graph of the derivative, we're going to find the derivative, and we're going to use the derivative in this case to find all the relative minima. This is the notes that you should have from the last video. I recopied it here. Make sure you have this in your notes if you don't already. We're going to use these facts to solve this problem here. Okay, so my first step, as the first step often is to find these minima, is to take the derivative. And I'm going to use power rule to do that, right? So negative 6x squared, this should be second nature to you by now, plus 54x minus 84 is my derivative of f, so that's f prime. Now, we want to find where the derivative is equal to 0. So I'm going to set this derivative equal to 0. Okay? So I've plugged in 0 for f prime because we know that these minimums must occur where f prime is equal to 0. Here's a good definition for you to know too. F prime, any point where f prime is equal to 0 is called a critical point. Okay? So that's what we're finding right now is the critical points of f prime. Okay? So essentially what this means, these are points that might be extrema. So that's a good thing to know. Good thing to have in your notes. Points that might be extrema. So, and I say might be because we also have to check that the derivative changes signs in order to show that it's an extrema. Otherwise, it might be, well, I'll sketch a graph of what it might look like if f does not change signs here in a second. And then I'm going to solve this now, and you guys have been doing this since probably your freshman year, maybe 8th grade, maybe 10th grade, I don't actually know. I'm going to factor out my negative 6 to start. Careful with your signs here. I've been doing this for 20 years and I still mess that up. Not quite 20 years. 6 times 14 is 84, so we have plus 14. Still equal to 0, right? Now, in the past, I've actually taught it this way too. What you might be inclined to do is just divide by negative 6 to get rid of it. We actually want to keep that because what we're concerned about is the signs of this thing eventually. So that negative 6 is going to affect the signs that we get. So we're going to keep that there. In the past I've taught it where you like cross it out, get rid of it. Don't do that. Keep it there. But we're going to factor this next term here. So that gives us negative 6. You can draw the x if you like to do that. We want two numbers that multiply to 14, add up to negative 9. So minus 7, minus 2 are my two numbers. And that gives me x equals 7, x equals 2 is the solution here. Okay? If we were doing this live, I would stop now and I'd be like, what did we just find? The answer's on your screen. So let's stop, think about it for a second. What did we just find? You should have said, we found the critical points. So critical points meaning the points where f prime of x is equal to 0. Okay? We're not done yet. So these are the points that just might be our solution. We're trying to find the minima. We need to check a little bit more closely. So we need to check whether f prime changes signs. Okay? Now, we just learned a thing in the last lesson that's going to help us do that. So I'm going to draw a sign chart. And it's good practice to draw these. Like as you get to the end of the problems, you probably don't need to draw them every time. But you should draw a couple as you're working them out. Let's see, my two zeros are x equals 7 and x equals 2. Oh, I did those in the wrong order, didn't I? 2 comes first. X equals 2 and x equals 7 are my two zeros. We count from left to right. Okay. And what I'm going to do now is I'm going to check the signs for each one. So I'm making a sign chart just like we did in the last lesson. By plugging in numbers, right? So here, I might use 0 So we'll check x equals 0. Well, x equals 0 gives negative 6 times 0 minus 7 is negative 7 times 0 minus 2 is negative 2. Okay, so I don't really care what this is, but it is negative times a negative is a positive times another negative is a negative. So this part is negative of my sign chart. So that means my function is decreasing here. Then from 2 to 7, so I don't know, I'll pick like 3. So x would equal negative 7. 3 minus 7 would be negative 4. And then 3 minus 2 would be 1. So here I have a negative times a negative is a positive, times another positive is a positive here. Okay? So I'm just plugging in numbers to check. You could type this into your graphing calculator like we did in the last one, but that's a little too much work for something that I can do in my head. You can probably do it in your head as well. Feel free to use your calculator though if you need to. Number 9, we should say 7 to infinity is our last interval. I'm going to pick 9. So x would be negative 6 times 9 minus 7 is 2, positive 2. 9 minus 2 is 7. So we have a negative times a positive times a positive. That's going to give us a negative. Okay. So here's my sign chart. Now we've done a lot of work here. So let's remind ourselves of what we're trying to find. We want the relative minima, right? So we're going to use these facts. We want the spot where f prime changes signs from negative to positive. Negative to positive. Okay, so that's here, right? So negative before x equals 2, positive afterwards. Okay, so x equals 2 is a minimum. X equals 7 then, we go from positive to negative, would be a maximum. So what our function looks like is, so this would be a graph of f. Function is decreasing until x equals 2, then it is increasing again until x equals 7, and then it is decreasing again. Okay, it's not the smoothest curve, but that's what f would look like. And notice it's not the same, right? We're no longer thinking like positive or negative, we're thinking increasing and decreasing based on the sign chart, because this is the sign chart for f prime. Okay. Remember, these sign changes are important. You can't just solve like critical point and say that's a max or a min. So, for example, if I had, this is the next page, if I had a sign chart that looked like this, negative, and we'll say this is x equals 5, and then negative again, x equals 5 would be nothing. It would be a critical point, but is not a max or a min. Okay, so what the graph would look like is maybe, well, it's negative, so we should go the right way. Something like this. So where it evens out for a second, but then continues to drop. So that's not a maximum or a minimum, right? So that's why it's important to check each of our critical points. So we must check our critical points. We must check the signs around our critical point. All right. So this is the meat of this unit. So go ahead and dive into these problems. Make sure you come back to the video if you're stuck.